Right, hello again. Today we're going to discuss lab reports. This will go pretty quick, but this is going to be the product from now on. Whenever you guys do a lab, it's no longer going to be do a lab, get results, give it to teacher, get graded. You need to produce something that can be reproduced because remember, now the goal is other people redoing your experiment. The lab report allows me to look over what you did and recreate it or improve on it if I need to, or at least find out what you found out to guide my research. Okay, here we go. This will go pretty quick. First thing we're getting on a lab report, of course, is a title. This title, you'll find a trend in all of our titles between graphs, data tables, lab reports. They're all going to follow the same layout. Remember this because it makes it much easier. Provide a title that is a description of your lab. I need to be able to look at your title and find out exactly what you were doing. The title should clearly identify the experiment's variables. That's the IV and the DV. Remember, IV affects DV is a great title. Okay. Purpose and problem. This needs to be stated within the first section. This is the place to explain what you are trying to find out or the problem you are trying to solve. Now, as we go through this, think back to the scientific method. This is your first step. Identify your problem as a testable question. So usually we phrase this as our testable question. Why did we spend the energy doing what we did? That's why we state that purpose. Observations and research. Again, we spend a lot of time becoming experts on our topic so that we can answer our question. So we want to tell people what we found. This is when you do research. This is the section of a lab report you will often look at because you don't want to have to recreate the wheel. So look at what other people found out if you trust them. That's why we use peer-reviewed research. Provide a summary of the information you gathered on the problem questions you are looking at. This is what led you to your eventual hypothesis where we become educated. We need to restate what we found. Now we get to the hypothesis. Hypothesis, we know it as an if-then statement. Again, this is our educated guess. This is a prediction of what the expected outcome of the lab will be. Again, we need to predict. We need to tell them what we think will happen because now we're experts. Relate the hypothesis to the purpose or problem of the lab. If I read a testable question, then I read the hypothesis, they should be related. If we change direction throughout our research, we need to change our testable question first so that the hypothesis and testable question match up. Try to focus your hypothesis on the information or research you collected. Don't change directions on people. It makes it very confusing to read through. So there's four main things that I will be looking for and four main things to a good hypothesis. Number one is that if-then structure you guys are great at now. So if, and then IV, and then what's going to happen to the DV. Groups after the IV, after the if. So the IV, the independent variables, can have different groups. For instance, I could have no water, 10 grams of water, milliliters of water, 20 milliliters of water, and 30 milliliters of water. I need to state that, if I can, after the if statement. So if I were to test 0, 10, 20, and 30 milliliters of water, then, and try to tell people what is going on. So the if statement really tells us what we're going to do in the experiment. How you are using or testing the IV after the if, and that's what we just mentioned. So not only mentioning the groups, but how are we going to use the groups, okay? So make sure to give that detail. We miss that a lot. How are we using the groups? And then finally, our prediction after the then. We need to make a prediction. We can't just state what we think is going to happen, okay? So if I have 0, 10, 20, and 30 milliliters of water given to somebody, a baby before bed, I think that they will have a greater chance of wetting the bed with 30 milliliters of water. Okay, so I've made a prediction as to what I think will happen, and I've mentioned the dependent variable, wetting the bed, in my prediction. Okay, so those are the four things I will look at throughout the experiment and the four things that I will grade on for a good hypothesis. For example, if a car rolled down a ramp with sandpaper, wax paper, or painted surfaces, then the car rolled down the ramp with wax paper will roll the farthest overall in meters. Notice I mentioned units. I don't leave a naked statement. Materials and procedures. Mr. Bierman went over this quite a bit with you. We need to list all the items needed for the experiment. Again, the goal is to have them recreate your experiment. Make sure to record the exact size and amount of each item required. Okay, this is something that's missed quite often. Please watch for this. Tell us what we need and how much we need. Be specific. Procedures. List and number each step. It should not be a paragraph. It should be a list. Think of a recipe. It's just like a recipe. Use complete sentences. Please do this. I get this missed all the time. And then should be clear enough for someone else to use as instructions for repeating your experiment. That is my guideline. Can I recreate your experiment? Oftentimes I'll have you give it to someone else and they have to recreate the same thing. Okay, so go over it, give it to a partner, have them look over it. That tells you how good your materials and procedures are. Sometimes these overlap. We don't need to give them all the basic stuff like grab a pencil. They know that. If I need to create something ahead of time, maybe instead of putting that in the procedures, I put it in the materials along with instructions about how to create, for instance, a paper airplane lab. I don't want to put in procedures how to make the planes, but I want to tell them how. So in materials, I tell them what type of planes they need and also maybe attach some instructions. Okay, so these can kind of overlap a little bit, but they're very important. These are the most important parts to recreating an experiment. Now we've done our experiment. Now we have our data. Okay. So we know these pretty well. We've gone over these before as well. So we have the data table. Be sure to accurately record your observations or data in the data table. These have specific layouts, so they're easy to read. They include title, labels, and units. Please don't forget these. And don't forget to average your trials when available. Okay, it can't always happen, but when it can, it's easier to read. Graphs. So we take that big, heavy data table and we make something that's easy to read. It's a visualization of our data. Use the appropriate type of graph for your data. If it's out of 100, if it's percentages, we use a pie chart. If it's over time, we're most likely going to use a line graph. And if it's comparing groups or single numbers, we're probably going to use a bar graph. Provide a title. Again, same layout for both of these that we used for the lab report. IV affects DV. Same for the data table, same for the graph, same for the lab report. Be sure to include labels, axes, columns, groups, and units. Okay, we forget units the most. I have to be able to tell what you were doing in your experiment simply by looking at your graph. I shouldn't have to look all over your lab report. Okay. And then conclusion. What happened and what the data showed. So what did we find spending all this effort? So the outcome, there's going to be three main parts we're going to look at. The first is the outcome. Was your hypothesis supported? Was that right or wrong? The claim. This is the qualitative statement. Remember L for letters. So it's what you observed in words. And then the evidence, which backs up the claim, which is the quantitative part, what the data showed, speak in numbers. The outcome, was I right or wrong, is backed up by the claim of what happened in the experiment in words, which is then backed up by the evidence, which is numbers. Numbers don't lie. You'll hear me say that all the time. Okay, we'll go over this again in just a moment. Finally, and this is where we get into in high school, this is the bigger picture. What happened and what was the outcome and what do I think? These are called reflections. I'm going to have you guys do quite a bit of these. How could you improve or what would you change? If I'm going to do your experiment again, I need to know what you would do different. And then what you learned from the lab. What did you get out of this? So questions for further research and investigation. Because any good experiment creates new questions, so what questions did you come up with? And then finally, application. Can you think of an analogous situation that applies to real life? A complicated way of saying, where can I use this info? You need to tell people what this means to science, and this is the application portion. It's a very important part. Why did what you do matters? Okay? And let's go back over to that conclusion. Again, just like the hypothesis having 4 parts that I'll grade against, I think a conclusion will have 3 parts. You've heard these before. First one, again, is the outcome, which is your hypothesis. What's correct, incorrect? You make this statement. My hypothesis was incorrect, which then we back up with a claim, which is a statement about the results of the experiment. Because the DART plane went the farthest. Notice I make a statement that tells me why I thought it was incorrect. You don't have to tell them every detail, just the main statement. And then finally, evidence, data or numbers for group to back up the claim. With the evidence will back up the claim. So we need to, if we can, include data for all our groups. If we cannot, if there's too many groups, that's fine. Try to give as much information as you can, though. So if, for instance, the DART plane went 21 meters, the glider went 18 meters, and the high-wing plane went 8 meters. By looking at these numbers and the groups, I noticed right away the DART plane went the farthest, which I mentioned. The DART plane went the farthest, which then backs up my statement. My hypothesis was incorrect. For make-up's sake, we'll say that in my hypothesis, I said the DART plane would go the least far and the high-wing plane would go the farthest. The data has proved me wrong, so I make that statement. Again, no one can refute my conclusion. In the future, you'll get used to your conclusion being graded. You'll have to stand up and defend your conclusion, so you want to back yourself up. So again, outcome backed up by claim, backed up by evidence, which is numbers. Numbers don't lie. No one can refute what you said. Okay? This concludes our lab report notes. Watch the following video.